Hello, I'm Roy Leep. I'm the director of Channel 13's Weather Service. WTVT is located in Tampa, Florida, and we're making this tape today to show you some of the facilities that Channel 13 uses in the preparation of its weather forecasts. The reason we're making the tape is because we've had so many requests from students to tour our facilities that we really haven't had accommodations to satisfy all those tours. And also there seems to be an ever increase in need for more information on career opportunities in meteorology. So we hope to cover some of those points today in a real tour of Channel 13's Weather Service. While we're outside here, we might as well start here and show you some of the equipment that we use. Around me, for instance, are the temperature sensing equipment located in a louvered shelter called a Cotton Region Instrument Shelter. It's in this small house that we have temperature sensing equipment that measures small changes in air temperature and also in humidity, the moisture in the atmosphere. Behind me are two rain gauges. Now we have two because we get so much rain in Florida. Yes, that's partially true. But we find that when there's extremely heavy rain, one type of gauge works somewhat better than the other. Let me give you an example of that. This first gauge actually weighs the amount of water that falls from the atmosphere. And it records this on a chart located in the bottom of the instrument. Well, now we'd hate to come out during a rainstorm and see actually how much rain has fallen. So to supplement the measuring amounts of rain that we receive, we have a second gauge. This gauge relays remotely every 1/100th of an inch of rain that falls to equipment inside our office. So not only do we have a continuous readout during the storm of how much rain has fallen, but then after the storm we can come out and check it with the more accurate weighing type measurement. So this is some of the ground equipment that we use, and there's plenty more. This type of equipment you see at many weather stations around the country, whether they're at a television station or whether they're part of government or military. And this is some that we have here at Channel 13. Behind me are the Channel 13 studios. It's in there that we have our Weather Central office, where we'll be taking you in a few minutes. And you'll also see a large microwave tower behind me. At the top of that tower, some 100 feet above ground level, is our radar antenna. The radar searches out some 315 miles in all directions. Radar is extremely important to meteorologists, and here in Florida, where we receive so much rainfall in the way of thunder showers and showers in our summer months, it's particularly helpful for a forecaster to know where the development of showers are, how fast they're developing or dissipating, and where they're moving. So the radar is a very important tool, and we'll be showing you much more about it later. Also on the tower is wind equipment. It's located at about the 75-foot level to get it up above any obstructions and to give us a pretty good clear measurement of wind direction and speed. And we'll also be showing you how that equipment reads remotely into our office and also into the studio. Well, that's about it out here, so let's take a look on inside in our Weather Central office. The main office of our Channel 13 Weather Service is located just off the lobby. And I might add that we have very comfortable quarters here. Also, it might be a good point to mention the history of our Weather Service in a little bit of detail. It was first established back in 1956. And back in those early days, we only had one meteorologist and a couple of teletype machines, and that was about it. Today, we've expanded to 6 meteorologists and a room full of equipment that you'll be seeing in just the next couple of minutes. The equipment, of course, and the meteorologists and all of our expansion has come about through a demand, through programming and through viewership. And students that have written in asking for more details on the weather, too. So from the demand of viewers, we've responded with more equipment to give us a more in-depth look at the weather. And that's what it's all about, really. Our programs are presented to give the viewer the best possible look at what the weather details are, the best synopsis of current conditions. We'll touch on a few of those points a little bit later. But this is the main office of our Weather Central. And behind me is a large rack full of hardware. These are all recorders or indicators that help us keep track of what's going on outside, what the weather is. It helps us to observe the weather, and it also records the weather. Although this office is open from 4 a.m. until midnight, 7 days a week, there are periods of time when we can't just stand in front of a thermometer or stand in front of a wind indicator and watch what the wind is doing. So many of the weather parameters that we observe are also recorded by pen and ink. In addition, we have an automatic weather station across the bay in St. Petersburg. St. Petersburg does not have an official National Weather Service office such as Tampa, and consequently we really don't know what the weather conditions are over there. But a few years ago we established our automatic weather station at the bayfront, and today we get continuous monitoring of weather parameters from the other side of the bay. So in this large rack of numerous recorders, we keep tabs on the weather both in Tampa and in St. Petersburg. And at any time we can tell you what the temperature, the humidity, or the wind is at either location. Up in the upper right-hand corner, for instance, are the wind dials. Now these wind dials are not for Tampa, but instead are for St. Petersburg. On the left-hand side, the wind speed, roughly 8 to 10 miles an hour now, and on the right, the wind direction. And the arrow in this case points the direction that the wind is coming from the north or from the north-northeast. Now this information is coming to us by telemetry over a landline into a receiver, and then from the telemetry receiver into these readout indicators. Directly below this is a barograph. In this case, it's a microbarograph, and a barograph records atmospheric pressure. The atmosphere has weight, and it's important for a meteorologist to know and understand the changes in pressure, since this ties into weather changes. So we have this instrument, this microbarograph, to continuously record atmospheric pressure. And it doesn't just record it, it magnifies each fluctuation 2.5 times. That's why it's called microbarograph. Below that is another recorder. Earlier we showed you an indicator for wind speed in St. Petersburg. Well, it's nice to know what the wind speed has been as well as what it is now. And on this recorder we have a continuous record of every lull and gust in the wind speed in miles per hour from St. Petersburg. It's all being recorded, and we can look back on the record at any time of day or night and see exactly what the wind was at that point. On down, we have a lightning detector. This detector permits us to discern electrical field changes within about 25-mile radius of our office. Sometimes these changes occur just before or during thunderstorm activity. And of course Central Florida has more thunderstorms than any place in the United States, so it's important for us to keep track of lightning and electrical disturbances. There's a small field mill located at our rooftop level, and all of the indications and fluctuations of electrical activity are indicated in this box and also recorded directly below on the recorder. So we can watch a thunderstorm develop, and then the lightning begin to occur, and then the thunderstorm during its dissipation stage. And when it's all over, we have a complete record, a complete signature of what the thunderstorm looked like as far as its electrical activity was concerned. In addition, there's a series of lights on this indicator that tells us when there is a potential threat of a lightning stroke within the immediate vicinity. This is important because although we have a radar to detect thunderstorms and showers, sometimes a thunderstorm might develop right overhead. There are some days when that happens. And believe it or not, the most difficult place for a radar to see is directly overhead. So in addition to keeping track of all of the electrical and thunderstorm activity within about 25-mile radius, it also tells us what's going on right over our head. Because in this office, we really don't have any windows to see. So occasionally we'll run out and take a look just to make sure that the indicator is working right. At the top of the center rack is another lightning monitor. This one keeps track of lightning strokes out farther away from our office, some 75 to 100 miles away. And as thunderstorms move into that range, we begin to pick up the electrical activity associated with them, or if one develops within the range, the same thing. Electrical lightning activity is recorded on the chart on the left, and on the right there's a small speaker that we can actually hear the crashes of thunder as static or spherics as it's called. Directly above the monitor is a small counter which keeps track of the actual number of lightning strokes. And by making a comparison of these strokes over a period of time, we can judge somewhat of the intensity of the storm, get a pretty good idea on a day-by-day basis how much electrical activity we've had throughout our area. Below the lightning monitor are two indicators. The one on the left is indicating pollution, and in our case we're measuring submicron particles in the atmosphere. The scale here actually runs from 0 to 250,000 submicron particles per cubic centimeter. So at the present time, looks like we're about 25,000 submicron particles per cubic centimeter. Over the years, and we've had this instrument in now for about 3 or 4 years, we've found our average to be about 60,000. And this is directly hooked up to a sensor on the roof that continuously pulls in the air, measuring the particles and then giving us a direct readout on the indicator here. To the right of the pollution indicator is just simply an aneroid barometer. Now I say simply an aneroid because perhaps many of you at home have an aneroid barometer. Sometimes barometers say rain, change, and fair on the face, and then they have some numbers, which in some cases are inches and others millibars, depending on what the unit of measurement may be. Well, this is a precision microbarometer. And all that means is that we get very fine readings of atmospheric pressure. Earlier, we showed you the microbarograph, which is recording the pressure. This is indicating the atmospheric pressure. It's a highly sensitive barometer, and it can take measurements down to the nearest 1,000th of an inch of mercury. That's our pressure reading. Now, below those two instruments and in the center of the racks, we have what we call a 4-point recorder. This recorder samples different parameters every 30 seconds, and there are 4 points involved. At present, it's indicating the outside temperature at Tampa, right outside our studios, out where we were a few moments ago next to the instrument shelter. In about 30 seconds or so, it'll change. It's getting ready to now and go to point 2, which gives us a reading of dew point outside our office. By knowing temperature and dew point, we can compute relative humidity. Then it'll go on to point 3 and give us the air temperature from St. Petersburg. And finally, point 4 is the dew point at our automatic weather station in St. Petersburg. Now remember, all of the St. Petersburg information comes back by telemetry, by a telephone landline, back by telemetry, into the receivers, and then into this particular recorder. One other item that this instrument records, over on the left-hand margin of the chart, we also receive the St. Petersburg rainfall. Every 100th of an inch of rain is indicated on the recorder. So there you have it. We can look back on this chart at any particular time of the day or night and see what the temperature and the humidity or the dew point, or whether it was raining, and if so, how heavily, in St. Petersburg and in Tampa. A lot of information on one large recorder. Directly below this 4-point recorder, we have several radios. This particular radio monitors several bands. The one below it is a crystal-controlled radio. And then to the left are several receivers and transmitters. All of these radios are used in our weather gathering communications system that we have. Several of the radios are used for picking up teletype, radio teletype, and radio facsimile signals that we put into appropriate printers. The transmitters are located for civil defense, and we have one transmitter which ties us in with Hillsborough County, another with Pinellas County. That's one for Tampa, one for St. Petersburg, and another which is an intra-county network of stations up and down the Florida West Coast. In the event of an emergency, if we were to lose our regular landline communications, we would still have and keep in touch with the outside world through those communication facilities. In addition, we have a radio, and when it's turned on, we can pick up the pilots in the area. Many times aircraft operators will talk about weather conditions in their general vicinity. So it's important to get their viewpoint of the weather as well as our ground viewpoint. And often they give us a lead to some type of weather situation that we had little or no knowledge of prior to hearing the broadcast. Above our radio receivers is a wind recorder. Now, when we were outside a few moments ago, we looked up on the tower and we said there's some wind equipment at the 75-foot level. This is the recorder that is tracking what those sensors are doing. Up there you saw a picture of the wind vane and the anemometer. The anemometer is the device which measures wind speed, and it is on the right-hand side of this record. Wind speed from 0 to 75, and of course we can double that should we have a wind storm of some type. Every little gust and peak wind speed is being recorded there. On the left-hand side, the wind direction is being recorded. Today it's from the northeast. And up at the top you can see the cardinal directions and the degrees of the compass indicating the direction of the wind. But the chart itself also has those direction points written on it. Again, we have a record of wind for every minute of the day and night and can go back at any time and see what the wind speed and direction might have been in Tampa. Above that, we have a 2-point recorder continuously giving us a record of tide on the left-hand side and water temperature on the right-hand side. Now, of course, tides are fairly important to a coastal location. This tide recorder is keeping a running account of the water height for Tampa Bay. And again, this information is coming into us by telemetry from near our automatic weather station in St. Petersburg. The blue line, or the line on the right, and the top scale is the water temperature at that location. That is, at the automatic station at the bayfront in St. Pete. So this is water temperature for Tampa Bay and water tide height for Tampa Bay. Together, they're two very important items. And we found that during storms, of course, storm tides can occur, and we can have a continuous readout of the height of the water from a very important location just off downtown St. Petersburg. And the water temperature helps us many times to determine whether convective activity might develop at night or whether sea fog might be probable. And then there's always those folks who are interested in what the temperature is for swimming or for skiing or water sports activity. Above that recorder is a pair of recorders that look very much alike. And they are, except they're indicating and recording two different items. The one on the left is rainfall, and the one on the right is for sunshine. The rainfall recorder is tied into the rain gauge that we looked at when we were outside. We said that that gauge indicated remotely every 1/100th of an inch, and this is the recorder that the gauge goes into. Every 100th of an inch is recorded on the chart and indicated in the little window right above the chart recorder. Now, the other recorder keeps track of sunshine, the number of hours and minutes of sun that we might have on any given day. Both of these parameters are of a great deal of interest to meteorologists, and they are of some assistance to us in forecasting. All of these recorders are used in our forecasting. Probably we don't use one any more than we use another, but all of them go into the input of making up a weather forecast and assisting us in knowing what the weather is like outside and how our forecast that we made yesterday is coming out today. Immediately to the left of our racks is the radar console. This is the main radar console. The radar observer sits at the desk. He has a curtain that he can pull around to keep out the ambient light in the room and thereby see the radar scope much better. This radar unit is a fairly new one, and we helped to develop and to design it. An electronics firm in North Florida built it, and it's only about 3 years old. It's solid state as far as most of the electronics. Of course, the scopes are tube type. This is called a PPI scope, or a planned position indicator scope. It's the main scope that we use, and if you've seen our weather programs, it's the one that we put on the air. The sweep is the antenna which is going around, and in this case, our transmitter, our radar transmitter, sends out a pulse, and it is reflected off of raindrops and returns to the large antenna that you saw on top of the tower. As it's returned, the energy is painted in, or we receive an echo on the scope. And by looking at where the echo is, we can determine what part of geography in Florida is being affected by rain, showers, or thunderstorms. Radar meteorology is a very important aspect of the whole field of meteorology. And there are a number of meteorologists that have really made it their professional livelihood to investigate radar echoes and determine better ways of detecting rain on radar. We're pretty happy with this set. It has a range of some 315 miles, and it automatically tells us the rainfall intensity also. By a series of lights up here, the radar observer can stop the antenna on a particular area of rain and actually determine what the intensity of the rain might be, anywhere from 1/100th of an inch to over 5 inches an hour. This same information can be painted in on the scope in a contour level. In other words, if we want to see just exactly where the heaviest rain is falling, by a series of buttons we can eliminate everything except just the core of the shower or the thunderstorm and then determine where it is. Up at the top of our console we have a television monitor, and you can see perhaps more clearly the full range that our radar operates on. This is actually a closed-circuit television picture of our remote scope, which is located in the studio. We'll be taking a closer look at it in a few minutes. However, this gives us a pretty good idea of what the picture looks like, and while you're watching it, I'll slow the sweep down and show you how we can stop it and then even back it up. Today there are no showers around the area, but you can see clearly the entire state of Florida, the Florida Keys, portions of the Bahamas, and on up even into southeastern Alabama and southern Georgia. Showers and thunderstorms can be seen and detected and observed over this entire area by means of radar. So the radar is an extremely important tool to us, and during periods of severe weather we use it frequently. Because it is closely related, its use is closely related to severe weather, we can make direct audio broadcasts from this desk. The microphone that you see here permits our voice to go directly out over the air, while the picture would be the television view of what the radar is seeing. This is the fastest way that we have found to put out important severe weather information in timely manner. Often severe storms, which might be associated with tornadoes or hurricanes, are what we call short fuse situations. They may only last for a few minutes, and you have to warn people as quickly as you possibly can. So to do that in just a matter of seconds, through a audio box that we have here, we can drop what we might have on the air at any moment, put on our television picture of the radar scope, and automatically broadcast over that picture audio which would describe the severe storm. It's been fairly successful, and we found it much more quicker than going in the studio and getting all ready for a long program. In addition to this method of broadcasting and observation, on the other side of the console you will see another scope. It's a different type than the one on the right, because we use it to determine the tops of the thunderstorms. It's called a range height indicator. And we stop the antenna on a particular thunderstorm, and we can look in the vertical what the radar might be detecting as far as the cross-section of the shower or thunderstorm looks. It's important to know how tall thunderstorms are, because generally speaking, the taller the thunderstorm, the more it penetrates up into the atmosphere, the more severe it is. And it's important from other aspects. We can determine its rate of growth, how fast it might be developing or how fast it might be dissipating or decaying. So this is another method of radar observation which we use extensively whenever precipitation is within range. The other small scopes and lights and knobs that you see around the radar help us in determining the status of the radar itself, keeping it up to peak power so that we're sure that we're seeing what we should be seeing and getting out as far as we should be with our beam. And also we can talk to other people in the television station and establish what we're going to do with our radar set, whether we're going to interrupt programming or whether we're going to use it on our regular scheduled programming as we do. So this is a radar console. We have several ranges, but our maximum range is 315 miles. And when we get into the studio, we'll see a little bit more how we use it directly on our programs. You know, communications is the most important part, perhaps. It's the keystone of forecasting. And we use radio communications, as you've seen, and there's a number of speakers that we listen to during important weather situations. Radio communications are only one aspect of the communications that we use for this weather service, and they're really not adequate because they're more local in nature. So we have to rely on facsimile machines to bring us charts and maps of the weather around the United States and other portions of the world as well. Through looking at these charts and analyzing weather situations, we're able to make a better forecast and to have a better insight into weather conditions as they occur around the state or the country or even the world. Charts such as this are prepared by a national staff in the National Meteorological Center in Washington, and then they're distributed by special lines across the country to weather services such as our own. This facsimile machine is one of two that we have that bring us the 18-inch size charts. Other machines that you see record radar pictures from other cities that we have, and also other satellite information that comes to us. Speaking of satellite information, we've been in the satellite business here at Channel 13 for over 10 years now. We started receiving the first satellite pictures from the first operational weather satellite that went up some years ago. It was an APT satellite, radioing the pictures down as the satellite passed overhead. But today we're using an exciting new tool. It's part of the GOES system. Not too many weather stations have this capability of receiving a weather satellite picture every 30 minutes. Here at Channel 13 we have such a terminal. This is nothing more than a receiver and a recorder, and actually photographic paper is in here, and as the signal comes from the satellite, the information is recorded and then it's processed just like a photograph, and the end result is really amazing. This particular picture is one of Florida, which was taken from a satellite called GOES, some 22,000 miles in space, and yet you can see objects 1/2 mile in diameter at the surface of the Earth, and that includes, of course, cloud elements. In this particular view of Florida, you can see many of the small lakes and rivers and streams. Cloud elements, only 1/2 mile in width, show up. So this is one type of satellite picture that we're using more and more frequently here at Channel 13. After all, we're in the picture business. And so being able to receive a current view of the clouds as they actually exist over our state or over the country is an exciting new tool. To be sure, it's an observational tool, but tied in with all of our charts and maps, it helps us in making forecasts. On this large pegboard, we have some of the pictures that we've received today. The top row are pictures mainly of the entire United States. They have a 2-mile resolution. That means that objects as small as 2 miles are visible. We receive pictures both day and at night. At nighttime, an infrared camera system is used, and the difference between temperatures of clouds and land and water are seen, such as in this picture here. It's an infrared view. In many areas you can see the clouds quite clearly, and the land areas even show up. The second row is composed of pictures of 1-mile resolution. Here the southeastern United States stands out quite clearly, and Florida with clouds over the Gulf and the Atlantic. But as the picture that I held up a few minutes ago, This is our greatest resolution, 1/2 mile. This is a magnification of the 2-mile view that you saw earlier. So we can see fine detail in clouds over any area of the United States or the Atlantic or the Gulf of Mexico. This is particularly helpful during hurricanes or severe local storms. And this type of satellite imagery is helping research meteorologists to better define storm situations and help them to analyze situations and to do research into the way storms develop, such as hurricanes or blizzards or other types of storm systems. In addition to satellite pictures and facsimile charts, we also receive a great deal of teletype information. This long file that you see is nothing more than weather reports from all around the nation. We receive these every hour. Some 400 cities throughout the United States, Canada, Mexico, and even in some foreign countries. And actually, each report consists of what the weather was at those cities every hour. So what we have here, for instance, I can tell you what Chicago's temperature was this hour. And these reports are coming in every hour. And if you were interested in what Chicago's weather was, let's say at 2 a.m. this morning, all I have to do is turn back to 2 a.m. and read the information off. Chicago is just one of several hundred cities that we receive hourly. And we keep them all filed so that the forecaster can come over and check what the weather is at these different locations. You know, there are many different people that live in Florida from around the country, and they're always interested in what's the weather back home. This is the way we find out. Hourly weather information coming in on teletype machines around the clock, 7 days a week. And the information is filed here so that all of our meteorologists can see it, assimilate it, and then broadcast it. Now we're going to take you into the room where these reports are received. This is our teletype room, and you can hear all the noise, and you can see why we keep it behind double glass and double thick doors. All the noise in one room. You can see also why we can't bring a tour in here. It's a rather small area, but it's a very important area because these rows of teletype machines bring to us continuously those weather reports that we had filed in the outer office. These machines all look alike, but they're all tied up to different circuits. Some circuits, for instance, bring us in surface weather conditions, while other circuits bring in upper air. Other circuits bring in information on severe storms and river flooding, hurricanes, tornadoes, severe type of information. And still others bring in international weather information from around the world. And we have another machine that we can actually switch a radio into and pick up radio teletype. In the event that we lose our landline communications, we can convert to radio communications and still have some data flowing into our office. These machines are all operating at 100 words per minute. They go day and night, 24 hours a day, 7 days a week. This end is all weather teletype machines. The other end of the room, we have United Press, Associated Press, those teletype machines, and also a photo facsimile machine. Those machines are used primarily by the news department, although occasionally teletype reports on weather come across there that we're interested in too. So they serve to supplement our normal weather teletype circuits down at this end. Now, while we're in this noisy room, I'd like to point out this large map behind me. It's a map that shows where all of our weather observers are. The Central Florida Severe Weather Network was organized back in 1959 to keep track of local severe storms across the state. Now, this is something that Channel 13 has organized, and each of these dots indicate where our weather observers are, and most of them have weather equipment. When certain severe weather conditions are observed, they phone the report in here, we analyze it, and if we think it's important enough, we put a bulletin out on it. And we tie our radar reports in with their reports. Now we have about 325 observers from coast to coast, and from as far north as Cedar Key to as far south as Fort Myers. So these observers are very helpful in keeping track of what's going on in our own backyard. Let's get back into a quiet area. Now, once the meteorologist obtains all the information he needs from the teletype sequences of current weather data across the country, and once he checks the radar, and once he looks at all of the recorders, and as he analyzes the facsimile charts, which here are posted behind me, as he assimilates all of this information, he begins to formulate his forecast. And all of this information is funneled onto a map. It's just a worksheet map. It's never referred to on the air, and once we've translated the information from it to the larger maps used in the studios, it's disposed of. But it's important because all of his ideas are put on this scribbly sheet. And the information of around the states and around the country, the temperatures, the precipitation, whatever, the forecast, all of this is then taken into the studio and translated to the bigger map. So it's important from that aspect. And the worksheet map is the end result, really, of the forecaster and all of the information he's gleaned from everything that we've just seen in the office. This is Studio A. It's our informational studio because all of the pulse news, sports, and weather originate from this room. As you can see, it's just a big room with a lot of lights and special wires and the cameras sitting to one side today. And behind it is this large wall which has the pulse signature and our Channel 13 signature on it. The sportsman is seated in this area, and I'm over in the news set right now. And then on over in the way, the weather set completes the rest of the area. The weather set really is the largest one because we're very mobile. We're not seated at a desk. We're walking either from the radar over to the area boards, or we're discussing something on a map. You know, we looked at the radar console over in the main office a few moments ago. This is the remote scope. And at this location, we have the similar controls, and we can do just about the same things that we could do at the master console desk. And this is the 315-mile range. Here's the 150-mile view. This is a pretty good general view of Central Florida, including practically all of our viewing area. And I can take control of the sweep, and I can stop it on a particular area and back it up. And I have automatic controls that I can sector scan any particular area. This is our closest range. It's the 25-mile area. And of course, Tampa is in the center. The cross right at the center indicates where our studio site is located. But this 25-mile range covers a pretty good area of the whole Tampa Bay section, on down to St. Petersburg, the bridge, and up towards Clearwater and the adjacent counties. Well, now that's one segment. That's the radar. And of course, we show it directly on the air. And it's used to every program, whether we have rain or not, because we feel that showing the radar, even when there is no rain, at least confirms that to the viewer. These are the large maps that I was referring to earlier. These are the ones that we use in the studio. And you'll recall that we had a worksheet map, and we translate the work that we do in our main office to maps like this. The figures that are written up here today are current temperatures or low temperatures that occurred this morning. This is just the state map that we use. But this particular set enables us to use several maps at one time. For instance, we have just what appears to be book leaves here that are hinged and that we can bring back and forth, and it gives us a number of surfaces that we can put these large maps up on for easy reference. This is the synoptic map that we show, or the large surface map with its fronts and highs and lows and precipitation drawn in. This is what the meteorologist really uses in depth and forecasts from. But of course, as I indicated earlier, many people are interested in temperatures all across the country, and here we have those. And these are taken right from those teletype machines that you saw and posted moments before we go on the air, so that we have a good sampling of the current weather conditions over the nation. On my left are a series of boards that we use indicating record temperatures, the current statistics. wind speed and direction, and in this case, these two dials are actually hooked up to the wind equipment that you saw earlier on the tower. The air pollution recorder gives you a written indication of what that indicator in our office showed. In other words, we have a past record here of several hours of the pollution trend. And finally, we have water temperature and forecast. All of these boards are finally shown at the end of our program and summarize the day's happenings and give a forecast to our viewer. So all of this information is compiled and focused to this one end, presenting the weather information to the general public. This is our main job here at Channel 13, and our major weather programs usually run 8 minutes in length. Now, I'm well aware that everyone who wants to be a meteorologist certainly might not want to be a television meteorologist. And I'm also aware that many of you are interested in career opportunities and potential. So I think that we'll discuss that now as we head back towards the office. Every year I receive letters and telephone calls from students on how do you become a meteorologist? What kind of schooling do you have to have? And all of those general questions about career guidance. It's really impossible to answer every situation, but what we've tried to do is establish a packet of information that we can send to teachers who are in the job of counseling for career guidance. This will help to give them some background and they can pass it along to the student. And then from there are several other opportunities and paths that the student can investigate. In this packet, we've put together several sheets explaining, for instance, the opportunities in meteorology, a weather study concept and course that the student can follow, weather study references, latest books and publications that the student can refer to, training aids that the student can look up for meteorology, even suggested courses which will meet the meteorological requirements for the National Weather Service. The National Weather Service, of course, being the government service that employs many meteorologists from coast to coast. This particular sheet, for instance, explains what type of mathematics is needed, physics, and what courses in meteorology in college the student should pursue. All of these things are available if the teacher will send us a letter and say that they want it. We'll be happy to send them out. In addition, we have a pamphlet from the government which talks about publications which are available. Unfortunately, most publications are becoming very expensive these days. We can't stock them to send them out to the teachers. Even this little pamphlet is now becoming unavailable, but we do have a limited number left. Channel 13 each year publishes its own little booklet on hurricanes, and this gives students some guidance and pictures explaining what we do at our Channel 13 Weather Service. In addition, in this packet there will be satellite pictures, some of the pictures that we looked at today in our tour, and weather charts and maps that the teacher can post on a bulletin board for the whole class. And then finally, we include journals and publications. These are scientific journals. They are a bit more technical and difficult to understand, but the reason that we include them is because it contains the name of our professional society, the American Meteorological Society. This society has career information available for students, and I strongly suggest that for the more serious student, the one who really seems to be heading towards a meteorological career, that student get connected with the American Meteorological Society as a member. The society has what it calls student membership, and for a nominal annual fee, the student can become a member and receive publications and keep up to date on what's going on in the scientific field. To obtain information from the American Meteorological Society, you can write them at 45 Beacon Street, Boston, Massachusetts, and the zip code is 02108. Or you can write me in care of Channel 13, and I'll be happy to send information along to you too. I hope there are some students in this class that are interested in becoming meteorologists. Perhaps some of you aren't quite sure yet, but by the time you reach the senior level of high school, you probably know whether you're interested in science, and you probably have a pretty good idea whether that science might be meteorology. If it is, give me a call or write me a letter or get together with the American Meteorological Society. We can head you the right direction. And I wish you good luck in your future endeavors.